In our video for today, we'll focus on the items involving shear and moment diagrams that most engineering students get wrong. Now, these items are not necessarily difficult to answer, but usually, dito natatrap yung mga students. Now, yung reason behind this is that most students fail to internalize the concept. And so, yung misconceptions become hindrances to arrive at the correct answer. And so, for our first example, we actually have a cantilever beam na mayroong internal hinge and also a propped end. And so, let's try to solve this one. First, we will solve for the reactions. Now, notice na itong load na to is inclined. And so, diba, if that's inclined, meron niyang vertical and horizontal components. And so, let's say we will isolate that load. Diba, magiging ganito. Yan. And then, this is the vertical component and this is the horizontal component. Now, para makuha natin yung vertical component, we have to multiply this load by 4 over 5 because the vertical component is 4 and then the hypotenuse is 5. And then, if we want the horizontal component, we will just multiply this load by 3 over 5 because this is our horizontal component and then 5 is our hypotenuse. Now, I forgot to write this load. This is actually 200 kN. And so, diba, to get the vertical component, we have, let's say, Py, that will be 200, and then multiplied by 4 divided by 5. And so, this will give us 160 kN. And so, ito na yan. And then, if we will get the horizontal component, we will have this one. Let's say, Px. And so, yung Px will be 200, and then multiplied by this distance, or the horizontal component, and then divided by the hypotenuse. So, this will be 5. Now, again, these ratios are the same sa cos theta or sin theta for this case, Py. Kasi diba, our sin theta is just equal to the opposite over the hypotenuse. And so let's say this is theta. Now diba, yung 4 is the opposite side, which is this one. And then our hypotenuse is 5, which is this one. And so equal lang to. Depende na yan sa'yo if you want to use the angle or if you want to use the components. But since distances yung binigay, it will be ideal to use the components. If angle yung binigay, that's where using the angle will be more efficient. And so our horizontal component will be 120. So yan. And then let's try to replace this load. Instead of writing that as 200 kN and then inclined, we'll just actually write these components. Itong 160 and 120. And so magiging ganito na. Ito na yung forces natin. And then first, let's try to isolate this segment. Let's say this is A, and then ito is B, and then this is C, and then this is D. Now since meron tayong internal connection, itong internal pin or hinge, we will actually isolate the two segments. Kasi this is our first member, and then ito naman, this is our second member. But first, let's try to check the determinacy. Diba, we have our equation which is R is equal to 3N. Now, our R is the total number of reactions. And so, diba, dito sa roller, we have one reaction which is vertical. So, let's say this is AY. And then internally, dito sa C, we have two reactions. Kasi this is an internal hinge. So, we have CY, and then we also have CX. And then dito sa fixed support, we have three reactions. Isang vertical, let's say dy, isang horizontal, which is dx, and then isang moment reaction. Now let's say that's clockwise. So this is md. And so diba, we have a total of 1, 2, 3, 4, 5, and then 6. So we have 6 reactions. So this will be 6. And then that should be equal to 3 times the number of members, which is dalawa. Kasi again, this is our first member, and this is our second member. So we have 2 here. Now, itong left and right side should be equal for the beam to be determinate. And so, diba, this will reduce into 6 is equal to 3 times 2, which is 6. And so, our beam will be determinate. This is how you can check. Now, the next question that would arise will be, sir, saang segment tayo magsisimula? Will we start from here or dito, sir? Now, ito yung tip ko. If you are solving reactions when there are internal hinges, always check kung saang segment yung determinate. Now, diba, if you will consider this one, let's say, segment CD, we will have this form. Meron tayong cantilever support, and then, let's say, we have 2 reactions dito, and then dito, tatlo. And so, diba, if you will consider this segment, we have R equal to 5, kasi 2 plus 3. So, R is equal to 3, and we have 5 is equal to 3 times the number of members, which is isa lang, and so times 1. And so, we have 5 minus 3, which will become 2. So if we will consider this segment first, we will actually have an indeterminate beam. And so that's why we need to start from here. Erase ko na lang. And so if we isolate this one, we will have this beam. Yan. And so diba, we will have 2 reactions dito. Isang horizontal and then isang vertical. And so using R is equal to 3N, diba, yung R natin will be tatlo. We have 3 is equal to 3 times the number of members, which is 1. And so we have 3 is equal to 3. And so our beam will be determinate. And so we will first cut this segment. Now we can directly solve CX saka CY just by using our equilibrium equations. Now, diba, this is 2 meters and also this one. Now, since yung 160 is nasa gitna, CY and AY, which is here, kasi meron tong vertical reaction, they will just be equal. And then they will carry half of 160. And so by symmetry, we have AY plus CY is equal to 160. And then since yung dalawa are equal, we can just say 2AY is equal to 160. And so our AY will be 80 kN. And this is also equal to CY. And then by summing up forces along X, we have CX, which is going to the left, acting opposite to this one. And so CX will automatically be 120. So this is 120 kN. And so now, we have our reactions. And so let me just erase this one. Yan. Now, ito yung reactions dito sa first beam natin. And so now, since meron na tayong reactions for the first segment, we will transmit itong dalawang to dito sa second segment. And so, diba, if we will transfer this one sa kabilang segment, then our CX and CY will be acting opposite to these directions. Kasi diba, internally, we have to maintain equilibrium. And so, yung CY, instead of upward, that will become downward. And then itong CX, instead of going left, it will now go to the right. And so if we will illustrate that, magiging ganito na yung beam natin. Yung reactions. And so now, we can solve the reactions dito. Kasi diba, we have 3 reactions. Isang vertical, isang horizontal, and then isang moment reaction. And then ito yung reactions natin. Our MD will be 300, and then our DY will be 20, and then our DX will be 120. Now, you might be wondering saan ko nakuha yung values na to. And so I will just show you the solution. Now first, let's try to solve DX. Kasi diba, yan naman yung pinakamadali. Kasi we will just sum up forces horizontal. And so we have summation of forces horizontal, and then set natin to 0, we have, let's say this is DX. We have dx equal to this force. Kasi yan lang naman yung horizontal reaction natin. Force. So we have 120 here. And so that's why this is 120. Now, to get dy, we need to sum up forces vertical. And so summing up forces vertical, we will have this force, which is 80, and then going downward, so that will be minus 80. And then we have itong dy, so plus dy. And then we also have the resultant reaction of this distributed load. And so diba, that will just be this load multiplied by the length. Now again, hindi ko nasulat, this is 6 meters. And so we will have a resultant dito sa gitna. And then that will be 10 kN per m multiplied by 6 meters. And so yung m magka-cancel. And then we will have 10 times 6. That will give us 60 kN. And so we will actually add 60 kN. Kasi again, our distributed load is acting upward. And so yung resultant force will also be acting upward. And so kaya positive. And so we will set this one to 0. And then solving dy, we have 80 and then minus 60, which gives us 20 kN. And so dito lang yan galing. And then finally, to solve MD, we will just be taking moments about D. And so we have this one, a summation of moments about D, and then equal to 0. We have this force, which is 80 kN, and then multiplied by the moment arm, or the perpendicular distance. Now that's 6 meters. Kasi diba, this force forms a right triangle with our beam. And so ito yan. And so this is our perpendicular distance. And so I hope that's clear. So we have minus 80, and then times 6. Now sir, bakit minus? Now this is minus because let's say you are holding this point or the point at D, and then you will apply a downward force dito. Diba, your beam will rotate counterclockwise. Yan lang talaga yung dapat mong i-imagine. Just imagine that you are holding the moment center or the point where you are taking moments, and then try to apply the load and then simulate the movement in your head. And so now, we have this one. And then next, meron tayong resultant dito. And then, if we'll hold this one, and then we'll apply an upward force dito, our beam will rotate clockwise. And so that will be plus. So plus the force, which is 60 kN. Again, we are using the equivalent force or the resultant. And then we'll multiply this one by the moment arm. Now, diba, itong resultant dito, it just acts sa gitna ng distributed load. Kasi our distributed load is rectangular. And then yung centroid niyan is just basically dito sa gitna. And so this distance will be 3 meters or half ng 6. And so times 3. And then now we have our moment reaction at D, which is, as assumed dito, that's clockwise. And so that will be plus MD. And then set natin to 0. And so solving MD, we have 300 kNm. And so this is how you can solve the reactions. Now to make our solutions easier, we can just actually draw the shear and moment diagram for this segment, and then draw another shear and moment diagram for this segment, and then we will just combine the two. And so this is what will happen. We will try to draw the shear and moment diagram for the first segment. And so diba, for us to draw the shear diagram, we will first establish our zero line. And so this is 0. Now just assume that this is a straight line. Pasensya sa handwriting. So we will start from 0 dito, and then diba, we have a force here which is acting upward. And so aakyat tayo ng 80 kN. And so we will move up. Magiging ganito na yan. And then diba dito, wala tayong loading. And so kaya this is just a constant line. And then at this exact point, diba, meron tayong 160 kN na load. And so we will actually move down. From 80, we will move down 160. And so to get this value, we have 80, which is this one, and then minus 160, because that's acting downward, minus 160. And so we will have negative 80. And so ito na yan. And then from here, patungo dito, wala tayong loading. And so we will just draw another constant line patungo dito na point. So let's move to the right. And then at this point, we will move up 80 kN. And so aakyat tayo. And then our shear here will just be 0. And so this will be our shear diagram. And then again, hindi ko nasulat. This is 2 meters, and then ito rin. And so now, we can move to the moment diagram. Again, we will first establish our zero line. And so ito na yan. This will be 0, and then we will draw a line. Yan. Now diba, this is a positive constant load. And then if we have a positive constant, then if we will move 1 degree, magiging diagonal na line. And then yung direction will depend on the sign. If it's positive, yung diagonal line will go up. And then if the load is negative, our diagonal line will move down. Because again, yung n dito will be 0. Kasi diba, this is just a straight line. And then dito, since we are already in our moment diagram, we will add 1 degree. And so yung n natin magiging 1 degree. And so from here, patungo dito na point, let's say this is A, this is B, and this is C, we will actually move up paganyan. And then, that degree will be 1 degree. And so, this will be our line. And then, let's just project a line from here. Yan. Now, sir, ano yung value ng moment dito? Yung value ng moment dyan will just be this area. Kasi diba, we are still using the area method. And so, let's say this is A1. And then, ito will be A2. Now, our A1 will just be base and then multiplied by the height. Kasi diba, this is just rectangular. And so, this will be 2 meters times 80 kN. Again, yung unit ng V diagram is kN, or the unit of the load. And then, itong moment diagram will be kNm. Kasi diba, m times kN will give us kNm. And so, this will be 160. Yan. And so, this will be our value. And then, from here, we will now move down. Kasi diba, this load is negative because that's below the zero line. And then, diba, because these shapes are similar, we can say na A1 is just equal to A2. And so, our A2 will also be 160. However, the sign will be negative because this is below the zero line. And so if we are to write our solutions, we have MA equal to 0 kasi nandyan yan sa leftmost part or the left end. And then yung MB natin will be area 1, which is 160. Now again, this is KNM. Nakalimutan ko. And so, we have 160. And then to get MC, we have A1 plus A2. And so that will be 160 and then minus 160. And so that will be 0. And so bababa tayo. And then we will still use a diagonal line. Kasi diba, our N here is 0. And so dito, our N will become 1 degree. And so ito na yan. Ito na yung shear and moment diagram natin. Now for the other beam, I will just continue the solution sa OneNote because it's much more convenient. And then you will be able to see the whole beam talaga. And so now, I have redrawn here the first segment, which is segment AC. So this is segment AC. And then now, we'll be moving to this segment, which is segment CD. And so sinulat ko na dito yung resultant, which is 60 kN. And so let's first start dito sa shear diagram natin. Now, diba, we will be starting at 0. And then we will move down. Because meron tayong 80 kN load that's acting downward. And so from here, we will move down by 80. And so let's say nandito. So this is our next point. And then this is negative 80. So minus 80. This is our shear value. Notice that this is the same with this one. Because again, that's the same point, C, which is the location of our internal hinge. Now, at our internal hinge, the shear value will just be the same. Yan yung concept dyan. And then from here, we will actually move up 60 kN. Now, if we are to write our solutions, we have VCL, or the left shear value at C, that will be 0. Because, diba, we started from 0. And then our VCR, or the right shear value at C, that will be negative 80, which is this value. Again, just a reminder, if we have a concentrated load, we have left and right shear values, just like dito. However, I just did not show that earlier because it will be time consuming. However, I am just showing this one again for you to internalize the concept. And so again, we have negative 80 here, and then our shear value at point D will become VCR, and then plus or minus the resultant of the distributed load. Kasi diba, if we have a distributed load acting at a point and then up to a certain point, we will add the resultant from the first point so that we can get the shear value at the second point. Now this is our first point, and then plus or minus the resultant of the distributed load acting from C up to D. Kasi diba, if we have a distributed load, we need to add the resultant load to this shear value so that we can get the shear at this point. And so VD will become negative 80 and then plus the resultant load because this is acting upward, so plus 60. And so this will give us negative 20. And so we will actually move up. And so at this point, we have negative 20. Now sir, what will be our connecting line? Will it be a straight line or a curved line? Now, if you look at our load diagram, this distributed load has a degree of 0. And so our n will be 0. And so if we move to our shear diagram, we will add 1 degree. And so our n here will become 1, or a straight diagonal line. And so let's actually connect these 2 points using a straight line. So from here, we will extend this one up to here. And so this will be our area. Now in our first video, we have solved a trapezoidal area using the formula. However, for this one, let's just separate this into 2 shapes because we can actually project a line from here. And then now we can divide our area into 2 parts. And so let's say this rectangle is A1 and then this triangle is A2. And so let's just color this one. Now let's first draw our moment diagram. Now from 0, we will naturally move down because this whole area is below the 0 line. And so our next point will be somewhere here. Now sir, what will be the connecting line? The connecting line will be a curved line because again, the degree here is already 1 degree for the shear diagram. And so let's just move this one. Now adding 1 here, we'll have n is equal to 2 for the moment diagram. And so it will be a curved line. And then sir, what will be the orientation? Will it be like this or like this? We can check that using our leaf. Again, let's just copy this one. We have this leaf. And then let's try to check our shear diagram. So we started from 80 and then ended at 20. And so our magnitude has decreased. And then if we will check the sign, that will be negative. Because again, this whole area is below the 0 line. And so we have negative and then decreasing. And so we will actually follow this curve. And so from here, we will draw this one. And so it will be like this. Yan. And then sir, what will be the value here? Now naturally, the value here should be negative 300. Now this is because we have a moment reaction. Our moment reaction is 300 kNm. And then para ma-zero dito, we will move from negative 300 and then plus 300. And so this will be at 0. However, just to show you the solution using the area method, let's just use this one. Again, our moment at point C is equal to 0. Because this is our left end. And then our moment at D will be the area of the shear diagram from point C up to point D. And so that will actually be A1 plus A2, or this whole area. Now our A1 will be the area of this rectangle. And so that will be, this is 6 meters, and then multiplied by the height, which is 20. So this is 20 kN. And then we'll add the area of this triangle. So that will be 1/2 times the base, which is 6 meters, and then multiplied by the height. Now, be careful of this one. The height of the triangle is not 80. Because itong 80, it's this whole distance. And so, diba, ito lang yung height ng triangle natin. This one. And so, that will be 80 minus 20. And so, this will give us 60. And so, the height of our triangle is actually 60. So, times 60. Now, this is meters, and this is kN. And so, that's why we have kNm. Now, adding the two, we have 20 times 6 and then plus 0.5 times 6 times 60, we have 300. And then take note that the sign of this one will be negative. Now this is because this whole area is below the 0 line. We just took the absolute value and then we just considered the location of our figure. And since meron tayong reactive moment dito, we will actually have left and right moment values. And so this will be our left moment at D. And so we will have MDR, or the right moment value at D. And so that will be the left moment, which is negative 300, or isulat ko na lang yung MDL, and then plus or minus the reactive moment, or moment load. And so this will be negative 300, and then plus because this is clockwise, the reactive moment, which is 300. And so we will get 0. And so tama na yung solution natin. Again, always yan na we will start from 0 and then end at 0. And so we will move up to 0. And so ito na yan. Now, if hindi yan 0, it means that there's something wrong sa solution mo. Never doubt the concept. Kasi yung iba kasi, if their diagram will not end with 0, sasabihin nila na mali yung given or mali yung loadings. However, sila actually yung mali. And so just always understand the concept and then trust that concept. Kasi galing lang din naman sa science yan lahat. And then that's unchangeable. And so let's just color this one. Now again, an alternative solution to this one will be a plus b over 2 times the height. And then this will be, our a will be 80, and then our b will be 20, and then divided by 2, and then this will be our height. Again, just imagine that we are rotating the trapezoid. And so this will still give us, I will just show you, 80 plus 20, and then over 2, and then times 6, times 6, that will give us 300. Now, as you can notice, this formula is more efficient. But again, I'm just showing you this one para meron kayong alternative. Again, if we zoom out, ito yung shear and moment diagrams natin per segment. Ito. However, to draw the shear and moment diagram for the whole system, we can actually just combine itong dalawa. And then, ito rin. Always take note na yung moment value dito sa internal hinge will always be 0 because our internal hinge cannot sustain a moment. And so that's why this is 0 and also this one. And so joining the two, we will now have this one. And then this will be the shear and moment diagram for the whole beam. And so this is our final answer. Now I will just zoom in so that you can screenshot this one. And then after the discussion, try to solve the problem on your own because that will test your understanding. And then once you do it more and more, that will ultimately test your mastery. Now, in our next example, we will try to solve this beam. Now, this beam has a couple here. Again, in mechanics, a couple is a system of forces with a resultant moment of force, but no resultant force. And then the moment of a couple is defined as the product of either of the forces of a couple and the perpendicular distance between the line of action of forces. And so this is the perpendicular distance, which is 2 meters. And then that's called the arm of the couple. Now, diba, if we will apply these forces, ito saka ito, this member will rotate counterclockwise. Because if we push this one to the right, it will rotate counterclockwise. And then if we push this one to the left, it will also rotate counterclockwise. And so if we will see that in action, ito yung mangyayari. Yan. Again, if we will apply the forces, it will induce a counterclockwise rotation, which is this direction. And then, let's try to first write our reactions. Diba, for the roller support, we have one vertical reaction. And then for the hinge, we also have a vertical reaction. However, in actuality, this will have a reaction here, which is, let's say, CX. But we are not including this one because wala tayong horizontal force. Because yung horizontal forces natin kanina will just counteract each other. Kasi diba, we have 10 going to the right and then we have 10 going to the left. And so, magiging 0 lang din. And so, that's what I meant kanina na yung couple is a system of forces na merong resultant moment but walang resultant force because the resultant force will just be 0. And then again, if this will rotate, we can just reduce that into 20 kNm. Now sir, saan galing yung 20 kNm? This moment is just the force multiplied by the arm of the couple. Now our force is 10 kN. And then yung arm ng couple is 2 meters. And so we will multiply this one by 2. And so that's why we have 20 kNm. And then we can just reduce this load. And so ito na yan. Now, in order for you to see the whole beam, I will just transfer this one sa OneNote. And then doon na tayo magfo-form ng shear and moment diagram. And so first, we will try to solve our reactions. And so diba, we can get AY if we will take moments about C. Because again, this is A, this is B, this is C, and this is D. So taking moments about C, we can get AY. Now let's first reduce our triangular load into a resultant force. And so that will be acting somewhere here. And then let's say this is the resultant. Now this resultant is just the area of the triangle. So that will be 1/2 times the base, which is 6 meters, and then multiplied by the height, which is 20 kN per m. And so m will cancel, and then we will have, this will reduce into 3. So we have 20 times 3, which is 60. And so this will be our resultant force. And so I will just erase this one. Yan. And then sir, what is this distance? Now diba, if we have a triangle, that distance will be 1/3 of the base. If we are considering the distance from the height up to the centroid. And so this distance will be 1/3 of the base, which is 6 meters. And so 1/3 times 6, that will give us 2 meters. And so if this is 2, this will become 4 meters. Or you can get this one by using 2/3 of 6. That will still be 4. And so since meron na tayong distances, we can now solve AY. Kasi meron na tayong moment arms. Now let me just copy this one and also this one so that you won't be confused because we will be using these later. So again, taking moments about C, we have AY times the perpendicular distance or the moment arm, which is 6 meters plus 4 because we are considering towards C. That will give us 10 meters. However, I will just write here 6 plus 4 so that you won't be confused. And then we have this force which is acting downward. And so if we are holding this one and then we'll apply a downward force dito, then our beam will rotate counterclockwise. And so this will be minus. And then the resultant force multiplied by the moment arm, which is this distance plus this one. Because ito yung perpendicular distance natin. Yan. And so that will be 4 plus 4, which is 8 meters. And so this will be times 8. And then, be careful of this. Kasi dito mostly nagkakamali yung mga students. Hindi nila nasasali yung moment load. And so this will actually be, since this is counterclockwise, that will be minus 20. And then, we won't multiply this by a moment arm na. Kasi this is already in K and M. That's already a moment force. Now usually, nagkakamali yung mga students kasi they will multiply this by this distance, which is mali na because this is not a concentrated load. And so take note of this one. Do not multiply by the moment arm if it's already a moment load. And so to solve AY, we will set this one to 0. And so we have x times 10 minus 60 times 8 and then minus 20. That will be equal to 0. And so our AY will be 50 kN. So AY will be 50 kN. And so this is 50. And then to solve CY, we can sum up forces vertical. Now you can also take moments about A. Alternatively, if you are not sure with this one, but to make our solution more efficient, we will just sum up forces vertical. And so we have this one. So we have AY, which is equal to 50, and then acting upward, so that will be positive. And then minus 60 because ito yung resultant force. So minus 60 and then plus CY. And then we will not be including this one because that's a moment force. Hindi yan kasali. And so we will now set this one to 0. And so CY will be equal to 60 minus 50 if we will transpose these. So magiging 10. So CY is equal to 10 kN. And so I will just move this one. And so now, let's first project a line from our points. And so we have a line here, and also here, and then dito, and also dito. So let's say this is our 0 line for the shear diagram. And so this will be our shear diagram. And then let's say na ito yung moment diagram natin, yung 0 line. And so diba, for the shear diagram, we will start from 0. And then we will actually go up. Kasi we have a 50 kN load that's acting upward. So from here, let's go up to 50, which is let's say nandito. And so this will be 50. And then from here, patungo sa point B, we have a triangular load. And so we will actually subtract 60 from 50 to get the shear value at B. And so if I will show that one, we have VAL equal to 0 or the left shear value at A. And then our VAR will be 0 plus 50, which is 50. And then our VB will be VAR plus the resultant of the distributed load. Plus or minus. And then this will be, our VAR is 50. And then since this is acting downward, that will be minus 60. Kasi ito yung resultant. And so we will have negative 10. And so our shear value at B will become negative 10. And so that will be somewhere here. Yan. Now sir, what will be our connecting line? Will it be like this or like this? Let's try to check. Diba, our N here is already 1 degree. And so if we will move to the shear diagram, we will add 1. And so our N here will actually become 2 degrees. Kasi 1 plus 1. And then, let's try to check our leaf. Diba, we have this one. And then our triangular load starts from 20 and then ends at 0. And so the magnitude is decreasing. And then if we will check the sign, that will be negative because our triangular load is acting downward. And so negative and then decreasing, we'll actually follow this curve. We will draw this one. So magiging ganito. Yan. And then yung degree nito is 2 degrees. Take note of this one. Now again, dito usually nagkakamali yung mga students. Kasi when they are solving the areas for the moment diagram, they will treat this one as a spandrel, this area. However, that's not the case. But let's just explore that one later. And so let's continue dito sa shear diagram natin. Now, our shear at B will be -10. Yan. And then, since walang loading dito, we will just draw a straight line because our shear will just be constant. And so, our VCL, or the left shear value at C, will become -10 lang din. So, this is -10. And then, from -10, we will move up by 10 kN. And so, our VCR will be -10 and then plus this reaction force, which is 10. And so, we will have 0. So, from here, aakyat tayo sa 0. And so, yung shear natin sa D will just also be 0 kasi wala nang vertical forces dito. And so, we will just continue drawing a straight line dito. Yan. And then, this is also 0. So, ito na yung solutions natin. And so, now, if dito na tayo sa moment diagram, we will now be solving the areas. However, just like I said kanina, dito usually nagkakamali yung mga students because they will treat this one as a spandrel and then they will just directly use itong formula na to. Let me just move this one. Yan. However, you should always remember that if you're solving for a spandrel, then you should always consider the vertex. And so, we cannot consider this one as a spandrel. We cannot apply the spandrel formula because this is the vertex, but then we can't just stop here because our triangular load acts up to point B. And so, we can only use the spandrel formula for this spandrel. Or basically, at any point, let's say from here, patungo sa vertex. Like, for example, you cannot apply the spandrel formula for this one. If you have this point, and then also this point, and then you will apply it here. That won't work. However, what will work is, from here, patungo dito, you can actually use that because our ending and starting point should touch the vertex. Now, what do I mean by this one? Diba, by definition, the vertex of a parabola is the point of intersection of the parabola and the axis of symmetry. This can be either the lowest point or the highest point, or let's say, ito. Now, if we will consider this parabola, diba, we only have downward forces. And so, this will be our x-axis, and then this will be our y-axis. And then, diba, we can find here the vertex. Now, ito yung vertex, this point. Because, if you consider this parabola, diba, if you will extend that one, it will look like this. And then, it will actually concave upward. And so, diba, this is the minimum point. And so, yan yung vertex. And so, if we will consider the spandrel formula, we will always start from here. And so, that's why we cannot use the spandrel formula for this one. Kasi, this isn't the vertex. Again, our x value should start from the vertex. Kaya hindi to pwede. But if let's say, we'll consider this spandrel, ganyan, that will be okay because we are starting from the vertex and then up to this point. And then, let's say, we will consider this point and then extend tayo dito. This is also considered because again, we started from the vertex and then ended dito. However, what's not possible is this one. Let's say we will treat this one as our x and then this one as our y. Hindi yan pwede because yung x natin did not start from the vertex. And so you will get the wrong area if you will just use the formula. So be careful with this one. Now sir, what if, let's say, what if ganito yung curve sir? Nasaan ba yung vertex? Let's just say this is your shear diagram. Now dito usually nagkakamali yung mga students because when they encounter this example, andito kasi yung vertex. And so they will just assume na yung vertex is always at this point. However, for this case, the vertex will actually be here. Now bakit? What you always have to do is to make the parabola symmetrical. And so diba, if we will make this one symmetrical, it will be like this. Again, we are always considering upward or downward concavity. We are actually not considering this one. Kasi diba, hindi naman ganito yung curve natin. Yung curve natin is actually paganto. If we will extend that one. So let's just erase this one because this is wrong. And so we will consider this one. And so diba, if this is symmetrical, this will be our maximum point. And so this will be the vertex. And then likewise, if nandito tayo, we will actually consider upward concavity. And so that's why this is the vertex or the minimum point. Now what are the other cases? Pwede rin yan maging ganito. Let's say this is the zero line and then also this one. It may also be like this, paganyan. And then sir, nasan ba yung vertex dito? Will it be here or here? The vertex will be from here. Now, bakit? Because if we will extend this one, we will actually have a downward concavity. And then let's just say that this is symmetrical. And so, diba, this will be the maximum point. And so, this is the vertex. And so, what this means is that you can't treat this one as a spandrel. Because if you will use this one as your x, you will not be starting from the vertex. However, what you can consider here is you will start from here and then you can end at any point. So let's say this is your x, this will be your y. Let's say this distance. That will be considered because you are starting from the vertex. And then for this one, you cannot consider this one as your spandrel. If you will just consider this portion, you should always start from the vertex and then you can stop at any point. And so this can be your y and this is your x. And so dito, that's why we cannot start from here because this isn't the vertex. Now what if sir, ganito, paganyan sir, where will be the vertex? If we have this one, we can actually extend the curve patungo dito and then it will concave upward. And so this will be the minimum point. And so this will be the vertex. Again, ito na yung lahat ng cases. Just remember these. Again, always consider from the vertex if you are describing the height in terms of x. And so applying the concept, we need to project a line from here patungo dito. And so let's do that one. Ito na yan. And then let's label this distance as, let's say, x. And then this will be 6 minus x. Now sir, bakit 6 minus x? Yung whole distance kasi natin is 6 meters. And then if we subtract x, ito na yung distance na yan. Now sir, how will we compute x? Take note that this degree is 2 degrees. And so we can't actually use yung ratio and proportion sa triangles because this will be different. Ganito kasi yan. If we have a triangle, diba, our ratio will just be y is to x equals 5 is to 10. Ito yung mangyayari. However, if we have a curved line, we will actually apply the degree. And so let's say we have this one, and then this is curved. Let's say this is 10, and this is 5, and then this is y, and this is x. From here, patungo dito, our ratio and proportion will be y over x squared. Because yung degree nito is 2 degrees. And then dito, it's just only 1 degree. Kaya this is only x. Kasi if we will try to zoom in, this is actually x to the n. And also this one. This is x to the n. And then our n here is 1. And so we have 1 dito. And then dito naman, we have 2. Yan. And then we'll equate this one with our y, which is 5 over 10 squared. Now this is squared because this is also squared. Now sir, how can we remember this one? Just try to look at the figure. Kasi diba, for a triangle, we only need a small value of x to get a certain value of y. Kasi that's only linear. However, dito, we need a large amount of x in order for y to increase. And so that's why we are squaring x, because it must be significantly large to change our y value. And then I have a shortcut for this one. Kasi diba, this will ultimately become y over x to the n is equal to the height divided by the base. Diba, we can use this one. And so we can actually form an equation for y. And so that will be y is equal to h over b times x to the n. Meron din ng n dito. So this is to the power of n. And so we can use this shortcut. Now, nasa sayo na yan, if you apply this one, or just use ratio and proportion. However, ito yung shortcut. But ipapakita ko na lang yung ratio and proportion talaga. And so in order to solve x, we can use this ratio and proportion. Now, take note na this isn't only applicable sa x squared saka x to the power of 1. This is also applicable to x cubed, x to the power of 4, and so on. This ratio and proportion, that's what you have to remember. And so to solve x, we have the ratio y is to x squared. Now dito ka dapat careful. Kasi our value of y for x is not this distance. It's actually this distance. Because again, yung vertex natin is yung nasa right side. And so we will actually consider this whole spandrel. Yan. And so diba, our y will be 50 plus 10. Isusulat ko na lang, this distance is 50 plus 10. So this total distance is 60. And so you can't actually use this one sa ating ratios. Instead, what we will be doing is, we will consider the whole spandrel. So ito. Now diba, our y for that one will be 60. And so we have 60. And then our x, or the base, will be this whole distance. Now, para hindi kayo malito, let's just use x1 for this one. Yan. And then, let's treat this distance as our x. So, this is 6 meters. And so, 60, itong whole height is to the base of 6 meters. And then, we will square this one. Kasi meron tong squared. And then, we need to equate this one with this one. Now, sir, ano yung y na gagamitan? For this base, we will actually use itong y na to. Kasi diba, we can start from the middle up to the vertex. So we can actually apply the spandrel formula for this one. Now what is this distance? Diba, that's equal to 10. So we have 10 is to this base, which is 6 minus x1 and then squared. And so now we can solve x1. Let's just use our calculators. And so we have 60 divided by 6 squared, and then that's equal to 10 divided by 6 minus x1 and then squared. And so press shift solve, we have, let's input a realistic value, let's say 5. So we can get 3.55. Now if you don't want this one, you can just actually change this one into x. Let's say this is x, and this will be 6 minus x, so that our calculator won't be confused. And so let's try to solve this value instead of this value. So let's change this one into x. Ito na lang. And so let's change this one into x squared. And then let's try to input a realistic value. Let's say 2. And so we can actually get 2.449. Now I will just store this value into a so that I can use the exact value later. Or maybe to make this one more intuitive, let's just round up. Magiging 2.45. So our x will be 2.45 and then meters. Now, if this is 2.45, this distance will be 6 minus 2.45. And so that will give us 3.55. Diba? Ito yung result natin kanina. Because we interchanged this one and also this one. That's why ganun yung result. And so this is actually 3.45 and then meters. Now sir, what if I got it wrong and then I actually used this one and the whole spandrel? Ano yung mangyayari? This is what will happen. Let's say you treated this one as a spandrel, di ba magiging 50 or y is to x squared. And then let's actually relate this one with the whole spandrel. And so we have 60 is to 6 squared. And so solving x, we have 5.47. And so di ba, mali na yung answer. Kasi dapat, it should be 3.45. And so dyan ka dapat careful. Now, if you apply this formula, you can just actually get x directly. Now, diba, for this spandrel, this one, our y will be 10. So we have 10 dito. And then that's equal to h over b to the n, in which our h is 60 over the base, which is 6 meters. And then to the power of n, we have 2. And then multiplied by x to the n. So x, and then our n is 2. And so this is squared. So solving x, we have 2.45. This is another workaround. Now in our moment diagram, we will actually just consider the areas enclosed by the zero line and our curve. And so we will only consider these areas. However, we cannot apply directly a formula for that one because we don't have general formulas for that. And so what we will do here is we'll actually divide this into 4 shapes. Let's say this is our A1 and this is our A2. And then yung areas na excluded, I will just color it yellow. I mean orange. And so we have this area. And then let's just use another color for this one. Now diba, we can say that the area of this whole spandrel, ito, that will be A1, and then let's say this is A3, and then this is A4. And so we have A1 plus A3, and then plus A4. That will give us the area of this whole spandrel. So this is area of the whole spandrel. Yan. And so let's just move this one, and then I will copy this one. Now next, we can also see that A2 plus A3 will be equal to the area of this rectangle. So we have A2 plus A3, itong dalawa, that will be this rectangle. Now let's just label this one as the rectangle at the right. So right. And then our area 4 will just be this rectangle. So this is area of the rectangle at the left. And so now we already have everything. Now let's just divide this into different parts. Now let's first consider the area of the whole spandrel. Diba, we can actually use this formula. And so we have BH over n plus 1. Now our base is 6 meters. So we have 6 and then times the height, which is this whole height, which is 60. So this is 60, and then divided by n plus 1. And so our n is 2, and then plus 1. And so this will give us 6 times 60 divided by 3, that will be 120. So this is 120. And then this is KNM. Kasi diba, 60 is in KN, and then 6 is in meters. And so we have this one. Now para hindi sagabal yung units, I will just remove this one. Now next, we can solve A3. This is the area of the smaller spandrel. Ito. And so we have BH over n plus 1. Our B will be 2.45 because ito yung base dyan. So we have 2.45 and then times the height, which is 10 kn. So this is 10. And then divided by 2 plus 1. And so we have 8.166 or 8.17. So 8.17. And then next, we can solve A4. Now that will be the base, which is 3.45 times the height, which is 10 or this distance. And so this will be 34.5. And then for this rectangle at the right, that will be the base, which is 2.45 times the height, which is 10. And so this will give us 24.5. And so I will just color this one. This is A3 and this is A4. Now we have this value, and also this one. And so we can now solve A1. And so that will be A1 plus A3, which is 8.17, and then plus A4 which is 34.5. This should be equal to 120 because ito yung area ng whole spandrel. And so we have 120. And so our A1 will be 120 minus 8.17 and then minus 34.5. That will give us 77.33. I mean, this should be 3.55. And so this should be 5.5. And so this is 35.5. And so let's change this one. This is supposed to be 5. And so our A1 will be 120 minus 8.17 and then minus 35.5. And so that will be 76.33. So we have 76.33. And then next, we can solve A2 using this equation. And so we have yung A2 natin is unknown, and then plus A3 which is 8.17, and then this should be equal to the area of the rectangle at the right. And so ito yan, 24.5. So this is 24.5. And so yung area 2 natin will be 24.5 minus 8.17. And so that will give us 16.33. So our A2 will be 16.33. And so ito yung values na kailangan natin. Ito, saka ito. And so diba, dito sa moment diagram, we will start from 0. So this is our first point. And then, let's project a line dito. And so ito na yan. Now you have to take note na kung saan 0 yung shear, dyan mag-occur yung maximum moment. And so we actually have our maximum moment dito. Now sir, bakit nasa taas? This is because our A1 is above the 0 line. So naturally, we will move up. And then sir, what will be the connecting line? Will it be like this or like this? Again, we will just check our leaf. Kasi diba, we have this one. And then, our A1 is above the 0 line. So that will be positive. So we will consider this one positive, and then let's check if it's increasing or decreasing. Now diba, we started from 50 and then we ended at 0, considering this spandrel. So our magnitude has decreased. So we will consider positive and then decreasing. So we will use this curve. And so ito na yan. This will be our curve. And then yung degree nito will be third degree. Kasi diba, our n here is 2 degrees. And so plus 1, magiging 3. And then yung value nito will be 76.33, which is this one, or area 1. So we have 76.33. And then from this point, we will now move down. Kasi yung area 2 natin is below the 0 line. And so we will move down by 16.33 because yung sign nito is actually negative. Now this is because yung A2 is below the 0 line. And so that will be somewhere here. And then, sir, what will be the connecting line? Let's try to check. Diba, our A2 is negative. And then the magnitude is increasing. Kasi we started from 0, and then we ended at a certain value. And so negative and then increasing, we will actually follow this curve. Yan. And so we will draw this curve. Yan. And then if we are to write our solution, we have MA is equal to 0, and then our Mmax at x is equal to 3.55. Again, let's zoom in. This is the location of our maximum moment from the left end. Kasi diba, this distance is from here patungo dito. So Mmax at x equals 3.55. That will be MA plus A1. And so this is 0 plus 76.33. And so we have this one. And then for MB, which is at this point, we have A1 and then plus A2. Because we will now consider these areas. And so we have 76.33 and then minus 16.33. And so this will give us 60. So this is actually 60. Yan. And then from 60, we will subtract this area to get the moment at C. And so let's say this is A3. Let's just say this is A5 because you might get confused with this one. And so our A5 will be, since this is only a rectangle, we have the base, which is 4 meters, times the height, which is 10. And so we have 40 kNm. And so our moment at C will become this value, which is 60, and then minus this area, because again, the sign of this one will be negative because our area 5 is below the 0 line. And so minus 40 kNm. So minus 40, this will be 20. And so from here, we will draw a straight diagonal line because our n here is 0. Kasi diba, this is just a negative constant. So n here will be 0, and so our n here will be 1 degree. And then it will just be a straight diagonal line. Yan. And then let's say this is 20. And then dito rin pala, our n is equal to 3. Kasi this is also in the second degree. And so plus 1, we have 3. Now from point C patungo sa point D, we have no area sa shear diagram natin. Kasi diba, this is just a straight line. And so dito sa moment diagram, we will also draw a constant line. Kasi walang area dito. And so this will still be 20. And so this means na yung MDL natin will be 20 or the left moment value at D. Kasi diba, we have a moment load dito. And so we will have left and right moment values. And then our MRL will become 20 and then minus the moment load. Now sir, bakit minus? This is because our applied moment here is counterclockwise. And so that will be negative. And then yung magnitude is 20. And so we have minus 20. And so diba, magiging 0. And so tama yung diagram natin. And so from here, bababa tayo sa 0. And so now, we have this shear and moment diagram. Again, itong A4 saka A3 are excluded from the shear diagram. We are only including itong mga green areas. And so ito na yung diagrams natin. Now, we have our next example. This is not necessarily a difficult problem. However, most students are not aware of the technique that they can apply in order to solve this one. And so we have a spread footing that carries a distributed column load of 595 kN per m. And so this will be our configuration. Yan. And then, we have these distances. Now first, let's try to solve itong Q. Now at first, maybe this is hard to grasp, but itong distributed load, this is just the reaction of the soil. Kasi diba, just try to imagine that this is the soil kung saan nakapatong yung footing. Again, this is our column. And then, ito naman, this is our footing. And then diba, our footing rests on the ground. And so what supports it is the soil. And so yung soil, it provides a reaction throughout the length of the footing. And so yung mangyayari, just try to imagine na yung footing is supported dito, and then dito, and then dito, and so on. Now diba, we can just reduce that one into a distributed load. Because our footing kasi is supported at infinite points from this point up to this point. And so yan yung reason why we have this reaction. And then usually yung label natin dyan is Q. Now what this means is that ito yung soil pressure. And then just try to think of this one as a reaction. Yan. And so diba, in order to solve Q, we just have to sum up forces vertical. Now first, sa load transmission natin, itong column loads, yung lahat ng kine-carry niyan is usually reduced into a distributed load. That's why we have a distributed load dito sa column. And so diba, that will have a resultant reaction. Force. And so let's say, ito yan. And so diba, our resultant force will be the distributed load multiplied by this distance. Kasi ito yung length ng column natin. And so we have 0.4 meters. And then M will cancel. And then diba, this will become 238 kN. Yan. And then diba, yung soil pressure natin will also have a resultant. Now that will be Q times this whole distance. And so meron tong resultant dito. And then this is Q times 1.2 plus 0.4 and then plus 1.2. Or you can also say that this is 2.8. Now let's just use 2.8. So we have 2.8. And so summing up forces vertical, we have, diba, ito saka ito, they are acting at opposite directions. And so we can just equate the two. And so we have 238 is equal to Q times 2.8. This is our downward force, which is this one. And then ito naman yung upward force or the reaction, which is ito. And so we have Q is equal to 238 divided by 2.8. And so we will have 85 kN per m. This is 85 kN per m. And so we now have this one. This will be 85. Again, ito yung mga parts natin. Now, diba, at this portion, meron tayong upward load and then downward load. And so, diba, minsan, when we see this figure, mahihirapan tayo. And so what we can do here is we can actually get the net force acting throughout this length. Now, sir, how can we do that? Diba, we have these forces acting dito sa 0.4 meters. And so let's try to reduce these loads. And so, diba, we will have this one. Yan. Diba, this is 85 kN per m. And then this is 595 kN per m. And so we will just actually subtract the two. Again, if we will transmit this one, it will become like this. And then, we can actually subtract 595 and 85. So that this will become isang downward na distributed load. And so we have 595 minus 85. That will become 510 kN per m. And so instead of this one, we can just write it as 510 kN per m. And so this will be the system that we will analyze instead of the previous one. And so I will just copy this one. And so now, we will try to draw the shear and moment diagram for this one. And so first, let's label all the points where there are changes in loadings. And so diba, this will be point A, and then this will be point B, and then this will be C, and then this will be D. Yan. And then let's project a line from those points. And so let's extend a line dito, and also here, and then dito, saka dito. And so let's say this is the zero line for the shear diagram. So yan. And then this is V diagram. And then ito naman, this is for the moment. Now diba, we have tackled a lot of examples na. And so what we will do here is we will just fast track. So diba, our shear at A will be 0 because this is the starting point. And then our shear at B will become VA and then plus or minus the distributed load. And so diba, this will become 0 and then plus, because this is acting upward, yung resultant nito. And then that resultant will be, diba, this is 85 kN per M. So this will have a resultant of 85 times 1.2. And so this will give us 102. And so this is 102. And since this is symmetrical with this one, we can also say that this is 102. Yan. And then let's just also solve the resultant of this one. And so diba, this will be 510 times 0.4. And so this will give us 204 and then Kn. And so from here, we will add 102. And so our shear at B will become 102. And so we will move up. And then let's say, nandito yan. And so from here, let's connect a line. And then this will just be a straight line because our degree here will be 0. Itong lahat, this is n equals 0 because all of these are just distributed loads na constant. So this is 102. Yan. And then if we are to get VC or the shear at this point, we have VB and then plus or minus the distributed load or its resultant. And so diba, this will become 102 and then minus 204 because this is acting downward. So minus 204. So this will be negative 102. And so from here, we will move down. And so let's say, nandito yan. So this will be negative 120. And then our connecting line will still be a straight line. And so ito na yan. Yan. And then diba, this is 102. And so diba, since this is 102 and this is also 102, we can just say that this distance is 0.2 meters or half ng 0.4 kasi equal lang naman kasi to. So this is also 0.2 meters. Yan. And then from here, we will add 102. And so our VD will become negative 102 or the shear at C and then plus or minus the resultant of the distributed load. And so we have 102 and then plus 102. And so this will become 0. So aakyat tayo patungo dito. And this will be 0. And so let's say this is our area 1, this is area 2, this is area 3, and this is area 4. We will use this one for the moment diagram. And so we will now solve the moment values. And then for the sake of the discussion, I will just copy the leaf. Now, ito yung leaf natin so that we can directly know kung ano yung connecting lines natin. And so, diba, we are starting from 0 for the moment diagram. And so, our MA will become 0. And then next, we have MB. Now, our MB will become MA and then plus or minus the area of the shear diagram. And then this area will be from A to B. And so, diba, this will become 0 and then plus because this is above the 0 line. And so, that will be, since this is a triangle, 1/2 times base times the height. And so we have A1. And so this will become 0 plus 1/2 times the base, which is 1.2 meters, and then multiplied by the height, which is 102. And so we have here 61.2. Yan. And so that will be somewhere dito. Yan. And then this is 61.2. And then, sir, what will be the connecting line? Let's try to check our diagram. Diba, this is positive because it's above the 0 line. And then the magnitude is increasing kasi it's from 0 patungo sa 102. And so positive and then increasing, we will follow this curve. And so ito na yan. Yan. And then diba, at this point, which is between B and C, there is a point of 0 shear. And so diba, what will occur dyan is the maximum moment. So let's just write here, this is the point of 0 shear. And so dyan mag-occur yung maximum moment. And so let's project a line from that one. So let's say ito. Yan. And then this is actually the maximum moment. Now let's try to solve that one. Now diba, our Mmax, which is at x equals 1.4 from the left end, that will become MB and then plus A2, which is this area. Now sir, bakit 1.4? Kasi diba, this is 1.2 and then plus 0.2, that will become 1.4. Let me just clarify that. And so next, this will become, our MB is 61.2 and then our area 2 will just be the area of this triangle. And so that will be 1/2 times the base, which is 0.2, and then multiplied by the height, which is 102. And so this will give us 61.2 plus 0.5 times 0.2 and then times 102, that will be 71.4. And so this is 71.4. And then sir, what will be the connecting line? Diba, if you look at our shear diagram, our load is positive because this is above the 0 line, and then it's decreasing because it started from 102 and then ended at 0. And so positive and then decreasing, we will follow this curve. And so ito na yan. From here, we will draw this curve. Yan. And then diba, since our figure is symmetrical, then we can say na this is also 61.2 and then this is 0 because itong area 2 and area 3 are just equal, and then also yung A1 saka area 4. And so to speed up the process, let's just consider this one. However, our connecting line for this one will be the mirror of this one. Kasi diba, this is negative because yung A3 is below the 0 line and then it's increasing. So we have this curve, negative and then increasing. And so ito na yan. So let's just copy this one and then we will flip it and then let's just move this one. Now this is para symmetrical talaga yung figure natin. And then let's also mirror this one. Kasi diba, this load will be negative and then decreasing because this is below the 0 line and then the magnitude decreased from 102 down to 0. And so we have negative decreasing, which is this one. I hope that's clear. And so we can actually mirror this one. And so diba, we will have these points. And so now, ito na yung diagrams natin. Yan. And then let me just clarify that MC is equal to MB. And then MD is equal to MA. This is by symmetry. And so I hope this is clear. Now, we will try to deal with our last example. Now, it's easy to form the shear and moment diagram for this beam. However, the part where most students get wrong is the verification of the area. I mean, computing the value of the moment using the shear diagram. Kasi meron kasi tong mga tricky na part. And so we will try to solve this one. Now first, let's try to solve our reactions. And then we will just divide this one into two shapes. And so diba, we can project a line from here. Yan. And so we have a rectangular distributed load and a triangular distributed load. And then diba, the height of the triangular load will be this height from here only up to here. And so that will be 10 minus 4. So 10 minus 4 will give us 6. And so this is for the triangular load. And then diba, since we are dividing this into two shapes, we have two resultant loads. One for the distributed load and then one for the triangular load. Now sir, what is this resultant? Diba, that will be, let's say, resultant of the rectangle, that will be the base, which is 6, and then times 4. And so this will be 24, and then kn. And then this distance will be half ng 6. And so this is 3 meters. And then yung resultant ng triangle, that will be the area of the triangle. And so that's 1/2 times the base, which is 6 meters, and then multiplied by the height, which is 6 kn per m. So times 6. And so this will be 18 kn. Yan. And then sir, what is this distance from here patungo dito? This distance, again, from the centroid patungo sa height, that will be 1/3 of the base. So 1/3 ng 6. And so this will be 2 meters. Yan. And so now, we can solve our reactions. Meron tayong isang vertical reaction, and then let's say this is A, and then this is B, so this is BY, and then we have a horizontal reaction, so this is, let's say, BX, and then meron tayong moment reaction, and so let's say this is MB. Now, if you look at our figure, our BX will just be 0, kasi wala namang horizontal force dito, so this is 0 kN. And then to solve BY, we will just sum up forces vertical. So summing up forces vertical, we have BY, which is acting upward. This should be equal to the total downward force. Now, diba, we have 24 and then plus 18, equating the upward force with the downward forces. And so we have BY is equal to 24 plus 18. And so this will give us 42 kN. Yan. So this is 42. And then to get MB, we will just sum up moments about B. And so we will have this one. This should be 0. So first, let's consider the rectangular load. Now, diba, that force is 24, and then it will cause a counterclockwise rotation about B. Kasi diba, if you are holding this one, and then you will apply a downward force dito, our beam will rotate counterclockwise. So this is actually minus. And then multiplied by the moment arm, which is 3 meters. So this is 3. And then next, we have 18 kN. And so that will also be minus. And then we'll multiply that one with the moment arm, which is 2 meters. And so times 2. And then we have MB, which is, in our assumption, clockwise. And so that will be plus, and then MB. And then this should be equal to 0. And so MB will be equal to 24 times 3, and then plus 18 times 2. And so that will give us 108. And so our MB will be 108. And so we will just place that here. So this is 108 kNm. And so I'll just move this one. And then let's now project a line from A and also B. And so we have this one. Now, diba, let's say this is the 0 line of the shear diagram. So this is 0. And then this is V diagram. Diba, the shear diagram will just be easy to draw. Because we already know that yung shear dito is 42 kN according to the reaction. Because again, I will just show you everything. Diba, we have VA equal to 0. And then our VB will become VA and then plus or minus the distributed loads or their resultants. And so we have 0 and then minus, because these are both acting downward, 24 and 18. So minus 24 and then minus 18. And so diba, we have negative 42. And then this is still the left shear value at B. Kasi we will have a right shear value at B due to the concentrated load of the reaction at B. And so our VBR will be the left shear value, which is negative 42, and then plus this concentrated load. So plus 42, that will give us 0. And so this will be 42 here. I mean negative 42. And then aakyat tayo, it will be 0 here. Now sir, what will be our connecting line? Diba, our load is acting downward. And so we have negative. And so we will actually draw a leaf pointing to the left. Yan. And then diba, our load is increasing because it started from 4 and then ended at 10. And so again, yung increasing is nasa right side ng leaf and then decreasing yung nasa left. And so we have again negative and then increasing. So we will actually follow this curve. And so ito na yung connecting line natin. Yan. And then we will just color this one. And so this will be our shear diagram. And then for the moment diagram, we have this one. We will first draw the 0 line. And so ito na yan. And then diba, naturally, our moment value here will just be 108 kNm. Kasi diba, our moment reaction at B is 108. However, dito usually nagkakamali yung mga students because they will just directly apply the Spangel formula dito. And then diba, our Spangel formula is BH over n plus 1. And then they will use that dito. And so they will have this one. Their base is 6 meters. And then yung height is 42. And then divided by n plus 1. And then diba, the degree of this one will be 2. Because itong triangular load, this degree is equal to 1. And so this will be 2 plus 1. And so that will give them 6 times 42 divided by 3. That will be 84. However, notice that this is different from 108. But diba, the moment value here should be negative 108. And so diba, this is wrong. Now sir, bakit hindi mag-work yung Spangel formula? Ito yung concept dyan. If you look at our loading, diba, we have a trapezoidal load which can be divided into a uniformly distributed load and a triangular load. And so that's why in actuality, we cannot apply the Spangel formula for this one because our vertex is not actually here. Now why is this? Notice that our degree for the uniformly distributed load will be 0. And so diba, these degrees are different. And so that's why we cannot apply the Spangel formula because our vertex is actually somewhere here. Nandito yan. Now sir, how will we be able to compute 108 just by using the area method? If hindi naman to mag-work, ito yung gagawin nyo. First, let's make the degree uniform. And so in order to do that, we will actually extend this line. And so magiging ganito na yan. We will extend this one and also this one. Yan. And so diba, we will now have a triangular load. And so our vertex is actually here along this line. Yan. I mean dito. Since we are extending this line, we will first solve for this distance. Now let's say that's x. Yan. And then in order to solve x, we will just apply ratio and proportion. Now diba, this triangle and this triangle are just similar. And so we can say that 10 is to 6 plus x. Again, we are relating the height with the base. So we have again 10 kN per m is to this whole distance, which is 6 plus x. And so 10 is to 6 plus x. And then this should be equal to the proportion of this smaller triangle. And so yung height niyan is 4 kN per m, which is this one. And then the base is x. And so we have x dito. And so using our calculators, we can solve x. And so this is 10 over 6 plus x equals 4 over x. And so let's solve for x. And so that will give us 4. So this is actually 4. And so now, since our vertex is actually somewhere here, considering the triangular load, we will extend this line. And so let's say, ito na yan. This is the extended line. And then diba, this will be our vertex. Again, in solving areas, we should always start from the vertex if we are to apply the Spangel formula. And so we will actually draw a line from here. And so ito na yan. And then let's say this is y. And then we will first try to solve this one. Now what we will be relating here in order to solve y will be the two spangels. First is this one, the smaller spangel. And the next will be the whole spangel, which is from here up to here. And so it will be like this. We have y is to this distance, which is again 4 meters. So this is 4 meters. Y is to 4 squared. Now again, this is 4 squared because the degree is 2. And then this is equal to the whole height, which is y plus 42. Because again, this is also y. And so the whole height of the spangel will be 42 plus y. And so we have 42 plus y is to the base. Now the base of the whole spangel will be 4 and then plus 6. Kasi ito yung distance na yan. And so this is 4 plus 6. And so now we can solve y. So we have x over 4 squared. And then that's equal to 42 plus x. And then divided by 4 plus 6. This is also squared. And so we will square this one. And so we have 4 plus 6. That will just be 10. And then squared. And so solving x, we have this value. And so this is actually 8. Yan. And so this will become 42 plus 8. That will give us 50. And so let's try to label our areas. Again, yung area ng shear diagram is only this green area. And then ito, let's say this is A1. And then itong smaller spandrel, let's say that's A2. And then itong rectangular area, let's say that's A3. And so diba, we can say that area 1 plus area 2 and then plus area 3, that will be equal to the area of the whole spandrel. And so this is area of the whole spandrel. Now let's say our A1 is unknown. And so we have A1 and then plus A2, which is this area. Now that's the area of the smaller spandrel. And so we will use BH over n plus 1. Now our base is 4 meters. And then our height is 8 kn. Because again, this is 8. And so we have 8. And then divided by n plus 1. Our degree here will also be 2. Because again, the whole loading is already a triangular load. And so n is equal to 1 dito. And so dito, it will be 2. And so this will be 2 plus 1. And then plus A3, which is just base times height. Since this is only rectangular. So that will be, the base is 6. And then the height is 8. And then this is equal to the area of the whole spandrel. And so that will be BH over n plus 1. Now our base will be 4 plus 6. Now again, this is 6. So that will be 10. And then our height will be 50. Kasi ito yung whole height. And then divided by 2 plus 1. And so now, using our calculators, we can solve A1. And so we have x, and then plus 4 times 8 over 3, and then plus 6 times 8. That will be equal to 10 times 50, and then divided by 3. And so press shift solve, we will have A1 equal to 108. And so our A1 will be 108. And then yung sign nito will be negative. Kasi diba, yung area 1 is below the 0 line. And so our MA will be 0, and then our MBL will be negative 108. And then our connecting line will still be this one. Ito. Kasi diba, this is negative and then increasing. And so ito na yung curve natin. Yan. And then this is negative 108. And then our MBR will just be negative 108 and then plus the reactive moment. Kasi diba, this is just clockwise. So plus 108, this will give us 0. And so aakyat tayo dito. Yan. And so now, we already have our diagram. By the way, yung degree of curve dito sa moment diagram will be 3. Now, diba, some problems are very difficult if you are using the area method, like this one, because the vertex can actually not be seen directly in our shear diagram. And so that's why, as an alternative to this one, we have the moment equation. Now, I will be discussing that in another video. And so itong cases na natakol natin, these are actually the tricky cases involving the area method. And so if you will be able to master the concepts, then everything will just be simple. Just try to practice and practice. Because once you develop mastery, you will be able to answer any problem. And so yung very important takeaway dito is that equip yourselves with the concepts. Do not just memorize formulas so that you will be able to solve any kinds of problems. Yan lang mga Lodi.